Good evening, mathematicians. It is Wednesday night, and I'm filming your lesson for Thursday, April 2nd. So here is what you need to do today. You do need to take out your journals because we're going to do another problem string. And today you need to write this on there. You need to write your date, and you need to write equivalent ratios problem string. Now, you could pause the video right now if you're not going to get this down because I'm going to try to go fast. So if you need to pause it at any time, please do that. All right, equivalent ratios problem string. What we're going to do today is we're going to be learning about equivalent ratios because oh great, you get a cat that's going to help me try to teach today. We are going to be working on equivalent ratios because sometimes you might have problems where people are walking or running. So this is Toulouse. Toulouse, you need to go. Go away. I'm sure he'll be back. So sometimes people might be walking or running various distances in different amounts of time. And sometimes we need to compare those. Like, how fast are they going compared to that person? And the best way that we can do that is like miles per hour. So I want you to think, like, if you're thinking about an hour, how would you think about an hour? An hour has 60 minutes in it, right? But usually when we talk about a pace, we talk about what is the pace that somebody is going, and the pace is actually the time per mile that they're actually going. So we have to calculate miles and minutes. That's what we're going to be thinking in today. All right, thinking about paces. The first thing that I'm going to do is I have my clipboard here that I'm going to use as my dry erase board to be writing problems on for you, but I also tried to be smart tonight and write down some of your problems on here. So we have word problems. The first one says, if a student ran 4 miles in 20 minutes, how fast is she running? What was her pace? And basically the question that they want to know is, how long would it take for her to run 1 mile? Again, I'm going to turn the problem towards you. And what you could do is you could pause your camera or the video right now. And if you want to write down more of this information, you can. All right. So the first thing that I'm going to do is I'm going to look at my problem, and it says if a student ran 4 miles in 20 minutes, how fast was she going? Well, I know when I drive a car, I always have to think of it as a ratio. My car can go how many miles per hour, right? It goes in miles per hour. That's how I think of it. So in this one, she is not going in an hour. She's just going in a minute. So I need to know how many miles per minute that she can go. And actually, in the problems that we're going to do today, it doesn't matter if you do it miles over minutes or you do it minutes over miles. What we're going to do today, we're going to all do the miles on the bottom, and I'm going to show you why in a moment. We want to know how many miles, how many minutes it takes her to go and do 1 mile. And so really, when we create this ratio table, in the very end spot, we really want to have them 1 on the bottom, just so that it kind of keeps it in our brain for us, like how fast she's going. So this student, they said she could go 20 minutes, 4 miles in 20 minutes. 20 divided by 4 is probably going to give me the answer, right? But what we want to do is, again, we kind of want to be creating these ratio tables. So this ratio table for this one, if I take it and I say 20, let me put the minutes over here so I don't have to write it again. 20 minutes, she could go 4 miles, right? So the goal is I want to get down to 1 mile, and in order to get 4 down to 1, what do I need to do to the 4 right there? Right, I need to divide it by 4. And if I'm dividing the bottom by 4, then what I really need to do is I would need to 20 divided by 4, and that's going to give me 5. So this student would go 5 miles every minute. Somehow I'm thinking I'm telling you the wrong thing. She would go 1 mile, because I've got my numbers backwards. 1 mile every 5 minutes. I had the information. I just have it backwards there. Because remember I said the ultimate goal is we want to find out how fast she goes in 1 mile. And that's what we're trying to do. Because remember, when we find out how much she's going per mile, we're figuring out the pace. That is what we want to figure out. What is her pace? All right. The next question that we have to do, it says, what if a student ran 2 miles in 20 minutes? How fast was he going, or what is his pace? So again, there's the question. Pause the video if you need. All right. If a student goes, I'm going to use the same ratio table. All right, minutes over miles. And I'm going to say if they went 20 minutes for 2 miles, I want to find out this right here, right? I want to know how many minutes did they go in 1 mile. That's what I'm really trying to solve. So on this one, it's pretty easy, right? You can figure out, what do I need to do to get that one to be 1? Divide this side by 2. So I must divide this one by 2. And that means my answer is going to be 10. For every mile that she runs, it takes her 10 minutes, or he. I believe this was a he. So he can go, it takes 10 minutes, or his pace is 10 minutes to 1 mile. Right? That's how we know on that. And another way that I could write that, I could just say 10 over 1, right? Minutes, mile. Or I could just get rid of the 1, because we know whenever we have an expression and we have a 1 underneath, we don't really need it. So it could just be 10 minutes per mile. Right, like that. So it all means the same way. So perfect. Let me get a fresh piece of paper, and we're going to move on to our third problem in our problem string. All right. On this problem, it says, if a student ran 8 miles in 40 minutes, how fast was she running? And the question becomes, how long would it take her to run just 1 mile at that pace? So again, you can freeze your video to write that down or to gather more information. And I'm going to look right here, and I'm going to do my same minutes over miles, because I want to get it down to figure out I want that answer in that top. That's where I'm going to put my question mark to figure out. So if she did 40 minutes over 8 miles, what do I have to do to get it down to 1 right here? Is there a simple way to do it? Of course there is. Divide them both by 8, right? 40 divided by 8 is 5. 8 divided by 8 is 1. So for every mile, it took her 5 minutes to go 1 mile. Did we answer our question? It said, how long would it take her to run just 1 mile at that pace? 5 minutes, right? All right. Now, the next problem that they want us to do is starting to get a little more tricky, but maybe you've noticed a pattern. On these, what did I do here? I had to multiply this, or divide this by itself, right? Divide this by itself. Interesting. All the way just to get down to 1. So maybe that pattern will follow suit for this one. Here's the problem. If a student ran 3 miles in 30 minutes, how fast was he running? What was his pace? I'll give you the problem. Pause if you need. All right. Same minutes over miles. All right. So 30 minutes to go 3 miles. Again, I know you can figure this out. We just divide each side by 3. 1 and 10. What if I asked you to compare a couple? What if I asked you, and I'm going to grab a fresh sheet of paper. If I ask you to compare these two? What if we compare the girl who did 4 miles in 20 minutes to the person that did 8 miles in 40 minutes? What do you notice about these two? Let's pull up our papers and see. When she did 8 miles in 40 minutes, it took her 5 minutes, right? And when she did 20 miles in 4 minutes, her pace was still at 5 minutes. What they want you to see on these two is these are the equivalent ratios. That's what we're looking at right there. So here I wrote it on a card, so I'm not going to even rewrite it. And again, you can pause anytime if you need. So she went from 40 minutes, we had to divide by 2, right? So we divided the other one by 2. And then on the top, we could still divide it by 2 again, and divide it by 2 again. Divide by 2, divide by 2 to get all the way down. So the 40 minutes, or 8 miles in 40 minutes, and the 1 mile in 5 minutes are considered equivalent. And here's what I need you to know, and I would like for you to write this down in your journals. Rates are equivalent when both numbers involved are multiplied or divided by the same number. This is a ratio of, divided by the same number. Thus, a ratio of 20 to 4 is equivalent to a ratio of 5 to 1 because both numbers have been divided by 4. So that's what we're looking at today, equivalent ratios. All right. Now, the reason this is important is because we are going to go on to the next part. We have a couple more problem strings. And again, I think, or one more problem string, but it has a few more problems in it. And I think that you're going to quickly see the pattern on these as well. All right. Let's say, and I want you to always think of these in context. All right. So I could just give you the problem and you could easily solve the math. I know you can, but I want you to understand why and what it really means. So on this next one, if a student walked a half of a mile, and here we're getting into our fractions, okay? A half of a mile in 30 minutes, how fast was he walking? What was his pace per mile? So on this particular one, I'm going to take those minutes over mile. And on this one, I'm going to realize that it took 30 minutes to just go 1/2 of a mile, right? So now on this one, what I need to do is I'm trying to get to that 1. This is why we're doing ratio tables, boys and girls, because I want you to be able to see that even with fractions, it's really the same kind of process, except what do I need to do to get 1/2 to turn into 1? Instead of dividing by a number, I actually need to multiply it by a number, right? And this one is 2. And I'm going to remind you that when we do multiplication, we go straight across, right? But when we do division of a fraction, we flip it. So this would be, like saying 2 over 1. And then you get it, it would be 2 over 2 or 1. So 2 multiplied by 2 equals 1, which means I need to multiply this side by 2, and it ends up being 60. So the question was, what was her pace per mile, or his pace per mile? His pace per mile is going to be, it would take him 60 minutes to do 1 mile. Because again, when it's the pace, where it says pace on this one, it says time per mile, not time per half mile, time per mile. So that means we need to actually increase it so we can get to the mile mark, all right? Time, I'll write it here again. Time per mile, that's what your pace is going to be. So let's think about these next ones, and I think you'll see that this is pretty quick. You're going to figure this out, all right? If a student walked 1/4 of a mile, I'm going to plug this information in already into a chart. 1/4 of a mile, and in 5 minutes, how fast was she walking? Again, what was the pace per mile? That's what I need to figure out. So here we only have 1/4 of a mile. What do I need to do to get 1/4 to equal 1? You can pause the video, because I know you guys can do that and figure this out. Or maybe you just know right away, 1/4, it takes 4 1/4 to equal 1 mile, or equal 1. So of course we need to just multiply that by 4. That's going to equal 1. Multiply this one by 4. That's going to equal 20. So her pace was, it took her 20 minutes to go 1 mile. That's how we would say that. All right. The next one, and I'm going to actually write the next two down and show you those. If a student walked 1/5 of a mile, 1/5 of a mile, all right, just making sure I'm on the right, 1/5 of a mile in 5 minutes, what was her pace? So again, this is where I want to solve for. That's my variable that I'm solving for. I want to know what the pace is per mile, right? That's what I don't know. The last problem that they have here is if a student walks 1/10 of a mile in 1 minute, how fast is she walking? What is her pace? So using this minutes over miles, 1/10 in 1 minute. How fast, again, we want to know what her pace is per mile. On this one, did you figure out what you need to multiply to get that to be 1? So you have to multiply the top by the same. So on the top one, she was going, it would take her 25 minutes to go 1 mile. And how about on this one? 10 minutes to go 1 mile. Pretty easy if you start to think about it in ratio tables. Now, your homework is listed up on the assignment on what to do. So I'm not going to say it right here. And that's your lesson for today. Please email me if you have any questions. And there will not be homework for Friday. You do have your spiral review that is due. And any of your papers, please remember to put your name on them before you take a picture and upload them into my shared math folder. So thank you, mathematicians. Have a good weekend.